Good morning. Hope you're all doing well. If any of you feel like showing me your video, that'd be cool. Your lovely little face this morning, so I can tell if you can see the screens and everything else. So, I have an announcement. I'll do that later. Also, I'll remind you about an exam later. But anyhow, in the last lesson, we started 17.1, and I got through a couple of pages of it, but I have 9 or 10 more pages left. So anyhow, a couple things about the last meeting. It's really important that you understand what 1 radian is. And the fact that if you hold up your left hand, 1 radian looks like it's about that. We don't really care about the degree measure of the radian. We just care about the way it looks, and that it's the measure of the central angle, which I define the central angle as an angle whose vertex is the center of a circle. It's the measure of the central angle theta of a circle that basically intercepts an arc that's equal to the radius. So anytime you have a central angle and that angle intercepts an arc and that arc is equal to the radius, regardless of the length of the radius, if those two things are equal, it will always form this angle. So if you don't believe me, do a couple problems and superimpose, put the papers on top of each other, hold them up to the light, and you're going to see that it's 1 radian, and it doesn't change. It always looks like that. So we were talking about classifying angles last time. We looked at angles in degrees. So we looked at an acute angle in degrees. We looked at a right angle, obtuse, and straight angle in degrees. I want to look at those in radians now. So an acute angle in radians is theta. So it's the angle that's going to be less than half pi. So remember that we saw that a straight angle is equal to pi radians. So we discovered what pi actually means. It's 3 radians plus a little bit more, which is a straight angle. So therefore, an acute angle, half a pi would be pi over 2. So the angle would have to be less than pi over 2 radians, and it would have to be greater than 0 radians. Now, this week, I'm going to mention this later. You are taking an exam today at 2:30, but you're going to have a vocabulary quiz on Wednesday at 9 o'clock. You're going to have to be able to put these types of things, type them on the keyboard. So with theta, just use a capital letter, A, B, or C. For pi, just use the word pi and then use, a slash to mean division. Talk more about that in a little while. Okay, a right angle then is pi over 2 radians, or half pi. And obtuse would be an angle that's less than pi radians and greater than pi over 2 radians. So not only do you need to know these definitions for degrees, you have to know these definitions for radians. And like I said, we're mostly going to be working with radians. So it's critical that you understand what 1 radian is and what parts of a radian are. So what I want to do right now is I want to take a look at some angles in degrees and radians. These are called the common angles. Initially, we are going to be working a lot with the common angles. I think Ms. Fresco introduced them to you in honors. geometry, you actually defined using right triangles how these angles came about and what the lengths of their sides are. We're actually not going to define them in this class. You're just going to have to believe the definitions and how they were defined. So what you're going to see me do right now is you're going to see me draw some angles in standard position. So just a reminder that an angle is in standard position if two things occur. First of all, the vertex has to be at the origin, and the second thing is that the initial side has to coincide or lie on the positive x-axis. So these are called the common angles. You have to know these. It's hard to pass anything right now if you don't know these. So what I want to show is the angle in standard position. I want to show you what it is in degrees. And then we're going to look at what it is in radians. So just a reminder, there are two ways. I think I told you this. Two ways to measure an angle: degrees and radians. All right, so let's take a look at 30 degrees. So now remember, in geometry, you looked at these using geometry, which was right triangles. So I will eventually talk about right triangles, but right now I'm introducing the trigonometry using the unit circle. All right, and I think this to you, but there's two different ways to teach trigonometry. One is using the unit circle, and the other is right triangles. Right now we're focusing on the unit circle. Unit meaning the radius is 1. So if I were to draw this unit circle, excuse me, and what we're going to do is we're going to divide the top into 6 equal parts. 1, 2, 3, 4, 5, 6. So pretend those are equal parts. So the reason why I'm doing this is because if I was going to graph 30 degrees, wouldn't this be 30, 60, 90? And then it would go on from there all the way to 180 degrees. It's harder to see with degrees, but if I showed you radians right now, this is going to make a lot of sense. Because since I divided pi into 6 equal parts, we have 1/6 of pi. So of in math means multiply. So instead of writing it like that, we're just going to say 1/6 times pi, which is pi over 6. So 30 degrees is equivalent to pi over 6 radians. And I still haven't drawn the angle yet. So let me show you the angle in standard position. So the vertex is at the origin. The initial side lies on the positive x-axis. And 1/6 of pi would be this rotation right there. And so that would be our angle theta. Okay, so let's look at another one. So that's one common angle. So in the next one, I'm just going to divide this into 4 parts. And so if I were going to graph this angle, pretend those don't look exactly equal, but they should be equal parts. Okay, so if I were going to draw this angle in standard position, the vertex is at the origin, the initial side lies on the positive x-axis, and there would be this angle here. So notice that I am drawing rays. I'm not drawing line segments. I'm showing the rotation with an arrow, and I'm naming the angle. So over here, if we have 1/4 of pi, that would be pi over 4 radians. And that is actually half a 90, which is 45 degrees. Let's continue on. The next angle in standard position would be this one. So now I'm not going to use this middle. I'm just going to erase it because I'm going to divide this into 3 parts. So remember, this pi was divided into 6 parts, pi was divided into 4 parts, and now we're going to divide pi into 3 equal parts. So now this angle with the initial side on the positive x-axis, the vertex at the origin. And now when we draw this angle, show the rotation, name the angle. These are all positive angles because of the counterclockwise notation. This would show 1/3 of pi, and 1/3 of pi would be pi over 3 radians. And it's easier to see this. It's harder to see the degrees. That's why we don't look like working with degrees too much. But this would be 30, 60, 90. It would be at the 60 degree angle. Okay, 2 more. So the next one, vertex at the origin, initial side lies on the positive x-axis. And now we're going to divide pi in half, which means we get half a pi, which means we have pi over 2 radians. And that would be your right angle, which is your 90 degree angle. So these are equivalent. Pi over 2 radians and 90 degrees are equivalent. One more. Yell if you can't see this, if it's too low. Actually, I have 2 more. What did I do? I didn't show the 90. That's okay. So if you see this one, from here to here and here to here, that rotation right there, called theta, is a half a revolution, which is pi. And in degrees, that would be 180 degrees. Yeah, I lied. There's one more. I'll just put it over here. So this angle in standard position, if I do a full revolution, beta this time, the degree measure would be 360 degrees. And it would be pi plus pi is 2 pi radians. Oh, sorry. Okay, so it's absolutely essential that you know these. You do have to memorize them. Make sure you know these. Everything we do is going to be built from this foundation. And so now what I want to do is I want to look at drawing and naming an angle in standard position and stating the quadrant. All right, so I think over here I'm going to write the steps of what we're going to do. This is also going to be a quiz in the near future. So these are the steps. Let me erase that. For drawing and naming an angle in standard position, which is actually the sheets that I copied for you. I'm giving you a lot of practice on that because you will be quizzed on this. So this is drawing and naming an angle in standard position. And we're going to also state the quadrant. Now remember, stating the quadrant that an angle lies in is dependent on the terminal side. So wherever the rotation ends, that's where we're saying the angle lies. Okay, so anyhow, here are the steps. So first of all, you're going to draw the coordinate plane. So what this entails, and I'm going to be real strict about this, you do have to label, like I did not do here. You have to label the X and Y axes, and you have to make sure that the coordinate plane has arrows on the X and Y axes. The second thing you're going to do is draw the appropriate fractional parts. So just like you saw me do here, you saw me divide pi into equal parts. If you're graphing in degrees, you would have to, if you're going to graph the 45, you'd have to show the 90 degrees and take half of that. So you have to be able to divide things into parts to prove to me that you understand fractions and that you can graph the angle close to what it's supposed to be. The third thing is you're going to draw the angle in standard position. The fourth thing is you are going to draw an arrow to show the rotation. The angle rotation. And 5, you're going to name the angle. With some Greek letter. And then you're going to state the quadrant. So you want to make sure you memorize those steps and that you're doing this on every problem that I ask you to draw, name, and angle. You need to do this. Now I'm going to do a bunch of examples. All right, I'm going to stop there for a second. Some announcements. First of all, do not forget your exam today, 16-1, 16-2 at 2:30 this afternoon. You do have 50 minutes to take it. I have posted everywhere and Remind, in the stream of Classroom, in the actual exam itself, that you must show work like you would normally show in my classroom. You must show the steps vertically and you must circle your answer because I'm going to be grading it by hand. If there are problems that require work, you must show the work. If not, you will not get credit for the problem regardless of the grade that you get on the exam at the end when you take it. All right. For this assignment 17-1, there's a lot of different parts. So I have not given a due date yet, but I will lead you along step by step and tell you what you should be doing so that you're not doing 100 problems, the night before it's due. All right, so this is what I wanted to announce. On Wednesday at 9 a.m. Now that is during our workshop hours. So at Wednesday, it's going to be around 9:05. That's when the actually, you know what, 9 o'clock, it'll be 9 o'clock. And you're only going to have 15 minutes to do it. It's a lesson 17.1 vocabulary quiz of approximately 10 words. So you don't have a lot of time to mess around with it. I last time told you to make vocabulary cards, and I hope you did that, and I hope you've been practicing them because on Wednesday you're going to have to be able to take a quiz. Now, the way you complete these definitions, they have to be complete sentences. So you want to avoid words like them, they, it's. So for example, if you were to define obtuse angle, you would have to say something like, an obtuse angle is an angle where theta, and I'll be specific about how I want you to do it. I'll say define an obtuse angle in degrees or radians. So in degrees, you would say it's less than 180 degrees and greater than 90 degrees. Well, our keyboard, first of all, doesn't have this theta. So what you're going to want to do is use A, B, or C capital letters. In addition, your keyboard may not have that degree sign. So it's okay with me to say 180 degrees. Now, normally you wouldn't do that, but we're doing this remote learning and we're restricted to our keyboard. So over here, you would write that A, B, or C is greater than 90 degrees. So that's if I asked you to define an obtuse angle. You would say an angle where B is less than 180 degrees and greater than 90 degrees. Another example, positive angle. If you were going to define a positive angle, you wouldn't say it's when. You would say it's an angle formed by counterclockwise rotation of a ray. So once again, a positive angle would be an angle formed by counterclockwise rotation of a ray. So watch your definitions. Make sure you're writing something that makes sense in a complete sentence. And that's on Wednesday at 9. Any questions right now about the exam today or the quiz on Wednesday? All right, so let's take a look at some of these. So I'm going to start out graphing in degrees. I'll do a few in degrees, then I'll do a few in radians. So for example, if you wanted to draw and name an angle in standard position, you had 315 degrees. Well, hold on just a second. That's not even in the top half, right? And so when you draw, so let's go through the steps. You're going to draw the coordinate plane. You're going to label it. You're going to draw the appropriate fractional parts. So you know, we're in degrees, you know this is 0 degrees, you know this is 90 degrees, and a straight angle is 180 degrees. Well, if you go 90 more, it's 270. And then one full revolution would be 360 degrees. So 315 degrees is in here. What you can't do is just go, okay, well, it's about that. Can't do that. You've got to divide this into fractional parts. And you're going to notice that doing this in degrees is harder than radians. You have more control with radians. But anyhow, so what you're going to do is think about this and go, okay, well, if I cut this in half, this would be 45 degrees. And 270 plus 45. Oh, I got it. So I didn't have to divide it into 30s. I could divide it that. So let me draw the angle now. So here is your initial side with the vertex at the origin, initial side lying on the positive x-axis. And if you went if you went a half a revolution and went to there with your arrow, I'm going to name this angle beta. 270 plus 45 is 315. So I can see what you did there. You went half a 90, and that would be what I need to see. So the coordinate plane, the appropriate fractional parts, draw an angle in standard position, draw the arrow to show the angle, name the angle, and all we need to do now is state the quadrant. So the quadrant just state the quadrant. One thing I didn't do, and this is really bad, you want to show the terminal side. Still a ray. So it's this ray that rotated, and there's your terminal side. It has to be done exactly like this. Notice all the arrows. You're showing an arrow of the rotation. You're showing the arrows with the angle. You're naming the angle. How about a negative angle now? Negative 210 degrees. I'm going to draw the coordinate plane, label it. Wondering, why am I not drawing the unit circle? You can draw the unit circle if you want. Right now, I'm just kind of focused more on the angle more than anything else. So we're not really doing anything with the unit circle in particular. So, but you could draw a circle if you wanted to. It's not really doing us any good right this second. So now remember, with a negative angle, you're going clockwise rotation. So we're going this way. So now this would be 0 degrees. This would be negative 90 degrees. And this would be negative 180 degrees. And this would be negative 270 degrees because we're going clockwise now. So here's your initial side. So 210 is over here somewhere. So the question is, how far from negative 180 is 210? Is it 45 degrees? Is it 15 degrees? Is it 30 degrees? So it looks to me like if we have negative 180 degrees and a negative 30, that would give us negative 210. So what I'm going to do right now is you're going to see me divide this. There should be equal parts, by the way. And when I say equal parts, I'm talking about these sectors. So if I counted by 30s, this would be negative 210. This would be negative, 240 and negative 270. So you're seeing how I'm getting these parts. So what I want is this negative 210. So that's going to be my terminal side. And I'm going to show the rotation with an arrow, and I'm going to name it alpha. So let me just go through all the parts here. I drew my coordinate plane. I showed appropriate fractional parts, how I got it. I drew the angle in standard position, initial side, terminal side. I showed the arrow to show the angle rotation. I named the angle alpha, and I need to state the quadrant. So since the terminal side is in quadrant 2, that would be quadrant 2. So these are all pretty easy. You know, the question is, what if it was negative 205? Then you would have to break the 30-degree angle down into 15 and 15, you know, and you'd have to break it down, you know, keep breaking it down into fractional parts, which is not easy with degrees. you're going to see what I mean when I graph some with radians. I'll do one more. Degrees. Draw the coordinate plane and label it. Show this information that that's 0 degrees, up here is 90 degrees, and if we divided this in half, 45, that doesn't look good, but that should look like equal parts. 45 degrees away would be the angle we actually want. So drawing it in standard position, initial side, terminal side, show the rotation. So I'm going to label theta. And then we want to state the quadrant. So this is in quadrant 1, the terminal side. Okay, so let's see what this looks like in radians. Now, when I showed you the common angles, I just stayed in quadrant 1 and quadrant 2. You didn't see me go into any other quadrants, which you're going to see now. So let's graph 5 pi over 4. So this is 5/4 of pi. So what does this look like? Well, if we want to draw and name an angle in standard position, what we need to do is you always focus on the denominator. And this means we want to draw the top. It's a positive angle. We want to draw it 4 equal parts on the top. 1, 2, 3, 4. 1, 2, 3, 4. Now, if it was a negative angle, we would draw the parts on the bottom. But check this out. This would be pi over 4 radians. This would be 2 pi over 4 radians, which is pi over 2. This would be 3 pi over 4 radians. This would be 4 pi over 4 radians, because we know a straight angle is pi, right? 0 radians over here. 4 pi over 4 radians. So we still haven't hit 5 pi. So with an improper fraction, we would have to divide the bottom into 4 parts. And you can see what would happen. What if this was 17 pi over 4? We might have to rotate a bunch of times to get 17 pi over 4. All right, so let's take a look at what we have here. We want to graph 5 pi over 4, so let me draw my initial side. All right, so this would be pi over 4 radians, 2 pi over 4 radians, 3 pi over 4 radians, 4 pi over 4 radians, 5 pi over 4 radians. So I always use the horizontal. Now here's what I mean by that. If this was 17 pi over 4 radians, I'm looking at this as 4 pi over 4 radians, 8 pi over 4 radians, 12 pi over 4 radians, 16 pi over 4 radians. Because remember, we were talking the other day that everything on this horizontal is going to be 0 radians, 2 pi radians, 4 pi radians, 6 pi. They're even. Over here are the odds. Pi radian, 3 pi radians, 5 pi radians. So if I was going to graph 17 pi over 4, I'm not going to just start count like that. I'm going to get tired of that. So anyhow, don't worry about that right now. So now we have this rotation. We'll call it phi this time. And that would be your 5 pi over 4 radians. So what quadrant we're in depends on the terminal side, which is quadrant 3. You could write this or not. I can see what you're doing if you do this. By the way, later on, I'm going to tell you that if you do not put degrees or radians, radian measure is implied. So when you just see this, radian measure is implied. So if you mean degrees, you want to put the degree symbol, because if you don't put the degree symbol, you mean 350 of those. So it's very important that if you mean degrees, you put the degree symbol. Otherwise, you're saying radians, which is not what you necessarily mean. So negative one, negative 2 pi over 3 radians. Draw your coordinate plane. And now this is a negative angle, so I'm going to divide the bottom into 3 equal parts, which means I don't necessarily want to use that line. I don't want it to confuse me. So to draw this into equal parts, you want 3 equal parts. You got to be careful and draw these so it looks like equal parts. Okay. So this would be 0 radians. This would be negative pi radians. Not degrees. Radians. Radians. So your initial side. So we're going clockwise now. So this would be 0 radians. This would be negative pi over 3 radians. This would be negative 2 pi over 3 radians. And this half revolution would be negative 3 pi over 3, which sounds about right, right? Negative 3 pi over 3 radians. So here we go. Show it, name your angle. So there's negative 2 pi over 3 radians. And what quadrant are we in? We would be in quadrant 3 again. I'm going to do one more where I'm going to show you where this is leading. Let's do something a little more interesting. How about this one? 13 pi over 6 radian. So first of all, it is a positive angle, counterclockwise rotation. The denominator tells you how many parts you want to make. So if this is 6, you're going to make 6 equal parts. If it was 17, you would make 17 equal parts. If it was 24, you would make 12 and 12 for 24 equal parts. So right now, we have 6 equal parts. 1, 2, 3, 4, 5, 6. And we try to make them look as equal as possible. So see, sometimes with the even denominators, we can keep the vertical axis. Other times, we just want to erase it because it's confusing having it. Now, since you notice that this is an improper fraction, this is going to be 0 radians over here, which means over here is going to be 6 pi over 6 radians. Well, we want 13. So not only am I going to have to divide the bottom into 6 parts, I don't want to count pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So I don't want to do that. I just want to look at the horizontal and say, okay, this is 6 pi over 6, so 6 more would be 12 pi over 6. So that helped me. So it's 1 revolution plus 1 more. So I kind of cheated, and I recommend you do the same. So here's your initial side. It's going to be 1 full revolution plus 1 more. Label it. So 6 pi over 6, 12 pi over 6, 13 pi over 6. Draw your terminal side. So 1 plus a 6 more. And what quadrant are we in? We end up in quadrant for drawing a name and an angle in standard position. What I want you to do is make sure you do this next. So vocabulary test on Tuesday morning. You should be able to do this now. There may be some other problems also in practice AB that's asking you to draw and name an angle in standard position. So there are some other problems that you can do. But this is the main thing, and I would stay on top of things by doing the other problems where they ask you to draw and name an angle in standard position. All right, does anybody have any questions? All right. All right, well, I do want to thank you guys for listening to me and following directions, because the last assignment went a lot more smooth. Everybody turned in their stuff. There were 2 people that turned in a late assignment, but it was only because they somehow didn't get the percentage. They did submit something, but the percentage wasn't there. So a lot better, so I appreciate that. Also, most people turned in 1. I just want you to turn in the assignment percentage. I don't want any PDFs or anything else, unless it's, a quiz or something that I'm telling you that I need the scratch paper for. You're not turning any PDFs or anything that I give you. You're keeping those for yourself. So basically, I'm trying to hold you accountable with the assignment percentage, but I'm not looking at the assignments for a grade. All right. All right, so the next vocabulary word that you want to put on your index card is coterminal angles. I would know this one. These are angles that have the same initial and terminal sides. So these are multiple angles that have the same initial and terminal sides. So I just want to show you what I'm talking about with this definition real quick. So here's what I'm talking about. I don't know what this angle is. Let's just say that's an angle. My initial side. There's my terminal side. I'm going to call it alpha. If I draw another angle with the same initial and terminal side like that and call it beta, those are coterminal. The reason why is because they have the same initial and terminal sides. I don't know if you can see this green marker. Try it though. If I did this, I'm gonna be able to see it, huh? let's see here. Let's try brown. See that? See how they all have the same initial and the same terminal side? And there's infinite. I could go around 20 times. And as long as they have the same initial and terminal sides, they're coterminal, whether they're positive, negative, whatever. If they have the same initial and terminal sides, they are coterminal angles. Now, we don't want to always have to graph. So if I ask, what is a coterminal angle of 15 degrees? We don't want to have to graph it all the time. We know that graphing is tedious. And so if I said, okay, well, give me a coterminal angle of 20, you don't want to have to graph that. So basically, all you have to remember is this. You can add or subtract 360 degrees or 2 pi. So 360 degrees is a full revolution in degrees. 2 pi radians is a full revolution in radians. And all you do is add or subtract these, and you can get coterminal angles. Real easy. So we don't have to draw them all the time. That would be a pain. All right, so I'll go over here, I guess. I'll probably only have time to do one of these. So here's what they say. They say for each angle, find the nearest to positive coterminal angles and the nearest negative coterminal angles. All right, so basically what they want is they want 2 positive coterminal angles and 2 negative coterminal angles. This is pretty easy stuff right here. All you have to remember is coterminal, angles that have the same initial and terminal sides. All I need to do is add or subtract a full revolution in degrees or radians. So let's look at degrees first of all. If you have 23 degrees, I'll just do one of each and then I'll be done with the lesson. 23 degrees, and you want 2 of the nearest positive coterminal angles, you just add 360, right? So you just take 23 degrees plus 360, which is what, 383? Done. Another one would be 23 degrees, and instead of 1 revolution, I'll double it. So 360 doubled is 720. So the next coterminal angle would be what, 743 degrees? Real easy. So if we want negative coterminal angles, we would take 23 degrees minus 360, full revolution. That would be negative 337 degrees. And the next coterminal would be doubling 360. And then the next would be negative. Pretty simple. I'll do one more and then I'll stop for today. Let's do one in radians. Negative pi over 9 radians. So if we graph this, we would divide the bottom into 9 equal parts. But we're not doing that. We just want to find 2 positive and 2 negative coterminal angles. So with this, what could we do? Well, and this is why I'm adding and subtracting fractions, because you have to do this every day of your life in trigonometry. To get a positive one, you would add 2 pi, and unfortunately, you have to get a common denominator. So you would have to multiply by 9 over 9. So this ends up being negative pi over 9 plus 18 pi over 9, which is 17 pi over 9. The next one, you would have negative pi over 9, and instead of adding 2 pi, you would add 4 pi, need a common denominator. So this would be negative pi over 9 plus 36 pi over 9, which would be what, 35 pi over 9? Pi over 9. You could write radians or not. Radians is implied though. And now if we want the negative ones, you would take negative pi over 9 minus 2 pi, get a common denominator. Negative pi over 9 minus 18 pi over 9 is negative, and a negative is a negative, and you add would be negative what, 19 pi over 9 radians. And finally, negative pi over 9, double it, negative 4 pi, get a common denominator, negative pi over 9 minus 36 pi over 9. A negative and a negative is a negative, and you add, which would be negative 37 pi over 9. So we haven't even gotten started yet. And you have to love fractions now. There is a reason why I stressed it in first semester. You have to feel really comfortable with fractions, because everything you do in this class will be parts of radians, part of a radian, and yeah, part of pi radians. And I'm going to turn the recorder off. That's the lesson for today. Have a great day. Good luck with your test. I hope you do well with it. And I'll take questions after I turn this off.